Now, we saw already when we're dealing with sets, we had the union rule. And if I was talking about the size of the union of two sets, I was actually using it in the previous section. The size of the union of two sets is going to be the size of the first set plus the size of the second set minus the size of their intersection. This is the union rule of, this is just dealing with the union rule of sets. But it turns out there's a union rule of probability as well, and it looks identical. The only real difference here is that instead of saying the size of each of these sets, we're saying the probability of these events. So the probability of the union is equal to the probability of the first plus the probability of the second minus the probability of the intersection. You have all the typical rules of being able to manipulate this because it's an equation. And so if I wanted to figure out what is well, I guess this is finding the probability of the union. If I wanted to find the probability of the union, and I know the size of the first, the probability of the first, the probability of the second, and the probability of their intersection, well, I can just use this rule. The probability of the union is equal to the probability of the first plus the probability of the second minus the probability of their intersection, which is 0.21. Oh, no, that's not right. 0.34 plus 0.21 minus 0.12. Plug that into a calculator, or just work it out myself. Let's see, that's 0.09. This would be 0.43. So the probability of the union of these two events would be 0.43. That is the probability of either the first or the second happening, or both of them happening.